In large High Sierra wallpaper, the low-hanging clouds in the background may or may not be related to the name. If you've felt like the last few Macos releases have been a little light, High Sierra won't change your mind. That's not because there's nothing here, but because most of Apple's development work this time around went into under-the-hood additions and updates to foundational technologies. Changing file systems, adding external graphics support, adding support for new image compression formats, and updating the graphics API to support VR are all important, and none of them are small tasks. But the UI doesn't change, apps get only minor updates when they get them at all, and multiple features continue to be more limited than their iOS counterparts. Updates like Mountain Lion and El Capitan have drawn comparisons to Snow Leopard for focusing on refinement rather than features, but High Sierra is the closest thing we've gotten to a no new features update in years. High Sierra is so similar to Sierra in so many ways that it's honestly pretty hard to tell them apart. It's not like the constancy of macOS is a bad thing. While the Mac operating system has been trundling along in a comfortable groove, iOS has been working its way through an exciting but occasionally awkward teenage phase, and Windows has swerved wildly from desktop OS to tablet OS and back again. On the other hand, it has been a while since I came away from a new macOS version thinking, yes, this software absolutely makes my computer indisputably better than it was before. What's here in High Sierra is fine. I just wish that there was more of it, or that what's here felt even half as adventurous as what's happening on the iPad. Table of contents page 2. High Sierra will run on all the same Macs that ran Sierra last year, though Sierra dropped support for quite a few systems that had been compatible with El Capitan the year before. Here's the official list: MacBook late 2009 and later iMac late 2009 and later MacBook Air 2010 and later MacBook Pro 2010 and later Mac Mini 2010 and later Mac Pro 2010 and later. When the system requirements changed last year, I was told that Apple wanted to bring its Mac software support life cycle more in line with the hardware support cycle. In general, anything made more than 7 years ago is officially considered obsolete, and Apple will no longer service or repair it if you bring it in. Happily, that doesn't seem to be a hard and fast rule. Those 2009 Macs are officially outside the 7-year window now, and all the 2010 models are sitting right on the line. Before Sierra, Apple hadn't changed the macOS system requirements in 4 years. Versions 10.8, 10.9, 10.10, and 10.11 all ran on the same hardware, and I'm hoping the Sierra-era system requirements stay the same for at least another year or two. Apple just isn't changing macOS all that much between releases right now, and, as long as that stays true, there's really no need to be as aggressive about dropping old hardware as Apple is with, say, iOS. For a handful of macOS features, mostly related to graphics and wireless communications, you'll need a system that's slightly newer than the minimum baseline. For continuity features like AirDrop and Handoff, you'll need a Mac with both Bluetooth 4.0 and a 5 GHz 802.11n or 802.11ac Wi-Fi adapter. MacBook early 2015 and later iMac late 2012 and later MacBook Air mid 2012 and later MacBook Pro mid 2012 and later Mac Mini late 2012 and later Mac Pro late 2013. And Apple Watch unlocking requires 802.11ac because of the way the software determines the distance between your watch and your Mac. This narrows the support list further. MacBook early 2015 and later iMac late 2012 and later MacBook Air mid 2012 and later MacBook Pro mid 2012 and later Mac Mini late 2012 and later Mac Pro late 2013. Finally, support for Metal and Metal 2 requires a relatively modern GPU. These Macs all include integrated or dedicated GPUs that support the API, though some earlier Mac Pros can also support it with an upgrade to a more modern GPU. MacBook early 2015, a newer MacBook Pro 2012, a newer MacBook Air 2012, a newer Mac Mini 2012, a newer iMac 2012, a newer Mac Pro late 2013. If you're using an older Mac that's compatible with El Capitan, the good news is that Apple will probably provide OS security updates for another year. I say probably because Apple doesn't publish macOS support life cycles like Microsoft does for Windows, but 3 years after release has been the norm since macOS 10.7 kicked off the yearly release cadence. Owners of some 2008 and 2009 Macs that are officially unsupported may also find that, as with Sierra, the hardware is similar enough to the hardware in officially supported Macs that they can install High Sierra without any major issues. You never know what kinds of problems you're going to run into when you try that sort of thing, but it's a way to extend the life of some older hardware beyond just installing Windows or Linux on it. Branding, installation, and the APFS conversion. Welcome to the High Sierra Setup Wizard. Transferring files from an older Mac. Please read this whole thing. A few setup screens have been condensed, helpfully. iCloud Desktop and Documents syncing is still here, and it's mostly the same. Vault encryption, new file system, same UI. Setting up Touch ID on a Mac that supports it. Setting up Apple Pay on the same Mac. The first 8 macOS releases, first called Mac OS X and later simply OS X, were all named for big cats. Then, with Mavericks, Apple started naming its releases after prominent California landmarks, opening up a whole world or at least a whole state of naming possibilities. First, Apple went with a beach. Then it went with mountains. Then mountains again. After that, more mountains. And now, finally, mountains. Maybe some kind of symbolism is at play here. Maybe the Mac has scaled some metaphorical summit. Maybe macOS has peaked. Maybe it's just scaling mountains beyond mountains because climbing mountains is what it knows how to do and it's unwilling to move on to a new hobby. Or maybe Apple just thinks mountains make sweet desktop wallpapers. It's hard to say. In any case, Apple is sticking with a familiar branding strategy for High Sierra. The release refinement of release cadence dates back to Leopard's Now Leopard at the end of last decade, and since then we've seen 2 more pairs in line: Mountain Lion and Yosemite El Capitan. High Sierra's name and the subtlety of its changes indicate that it's meant to cross Sierra's TS and its is. The installer icon and default desktop wallpaper are similar to Sierra's in that both depict mountainous regions in bright, saturated colors. High Sierra trades Sierra's reddish early morning haze for an orangey, autumnal vibe, but, stylistically, Apple's imagery in the 2 releases is of a piece. The installer icon mirrors the changes with the Sierra installer. High Sierra uses a representative image as its install icon rather than the color-coded X used from Mavericks to El Capitan. The arrow pointing at the installer icon is shaded more lightly now, which leaves me wondering whose job it is within Apple to tweak that arrow once every 3 years. In large 7 years of downloadable macOS installers, the process of installing the operating system is superficially the same as last year. You grab the installer from the Mac App Store. It can upgrade anything running macOS 10.8 or higher and run it in place, or you use a third-party tool, the terminal command, to make a USB install drive if you've got a bunch of Macs to install on. The installer is a 4.90 GB download, smaller than the 5.03 GB 10.12.6 installer but larger than the 4.78 GB 10.12.0 installer. Some installer bloat is to be expected as features are added and bugs are fixed. A one-way ticket to APFSville. If you have an SSD note in this section, we casually reference a few APFS features that we explain in more detail in the main APFS section later in the review. Of course, the High Sierra installer does do one major thing that the Sierra installer didn't do. Behind the scenes, it converts your boot partition from the long-standing HFS file system to the new APFS. Well, it does that for most Macs, anyway. Though most people will never even know what's happening, there are plenty of caveats and details to know about how the APFS conversion happens, the cases when it doesn't happen, and why it doesn't happen when it doesn't happen. If you're performing an upgrade install, the file system conversion happens automatically but only to your boot volume. Separate HFS or bootcamp partitions on your internal drive plus any external drives you've connected remain untouched, and only if your Mac uses an SSD. Apple told us that third-party SSDs installed in older Macs wouldn't be converted automatically, but I found some posts from people running the betas who say the third-party drives were converted. In any case, a fresh install on a newly APFS formatted drive will get you there. However, Macs with spinning hard disks definitely aren't converted automatically, and Macs with Fusion drives can't be converted or reformatted to APFS at all in the initial High Sierra release. This is despite the fact that APFS was partly built to improve the way Fusion Drive works, but more on that later. Early High Sierra betas gave you the opportunity to skip the APFS conversion via a checked by default box early in the install process. But at some point between then and now, Apple decided to put itself in the driver's seat. High Sierra can boot and run on an HFS volume, but if you're using an all-flash Mac, you'll need to jump through some hoops to use it that way, installing to an external USB drive, for instance, and then cloning it to the internal disk with disk utility. Even with the file system conversion, High Sierra doesn't take dramatically longer to install on a Mac than Sierra did. For example, on a 2017 5K iMac with around 300 GB of data stored on its unencrypted 1TB SSD, the install took 33 minutes, and installation on a 2016 MacBook Pro with 53 GB of data on a 256 GB SSD took a little over 28 minutes. These are relatively new, fast Macs, so you may find that things take longer on older models. Still, in no case should the APFS conversion take your system down 4 hours. Apple also says that your mileage may vary based on the size and speed of your disk, the speed of your Mac, how much free space you have, and whether the volume is encrypted or not. In theory, the conversion shouldn't be too disruptive. As Apple discussed at WWDC this year when it talked about the conversion process in iOS 10.3, the installer doesn't actually touch user data on the disk. Instead, HFS metadata is copied to free space on the disk, converted to APFS metadata, and checked for errors. If everything checks out, the HFS superblock is replaced with an APFS superblock, and the conversion is done with minimal risk of data corruption. Of course, minimal risk isn't the same as no risk. It's even more important than normal for High Sierra upgraders to make a full backup of the disks to confirm that there's nothing on the disk that you wouldn't be okay with losing before they run the installer. I've had no issues, but this installer will be downloaded and run millions of times. Edge cases are bound to crop up, and file system errors are usually impossible for regular users to recover from. Proceed with caution. As with iOS, the APFS conversion may save you some space, but at WASNT my experience. Starting with a 10.12.6 volume, I copied a 37.13 GB folder of miscellaneous documents, images, music, and movie files to the desktop. I then cloned 4.66 GB of that data to the downloads folder in an effort to see how the APFS conversion handled duplicate files. Before beginning the High Sierra installation, Disk Utility reported that I had 71.37 GB of free space available on my 124.32 GB test partition. After installation, Disk Utility said I had 69.95 GB of space free on my new 125.34 GB APFS partition. The 1 GB or so I gained was more than taken up by 1.74 GB of new other volumes stored in the same APFS container as my Macos install. It's probably good that converting to APFS does so little to touch any actual user data, but it makes APFS space efficiency features feel even more limited and situationally useful than they already are. This is something I'll revisit in the main APFS section of the review. The amount of space that a fresh High Sierra install takes up is slightly higher than the amount taken up by a fresh 10.12.6 install. On a 2012 MacBook Air, 10.12.6 used 10.23 GB of a 120.1 GB HFS volume. In 10.13.0, the volume size increased to 121.12 GB, presumably because of APFS, but the OS took up 11.18 GB of space and other volumes took up the same 1.74 GB. Notes on HDDs and Fusion drives: for volumes that aren't automatically converted to APFS, you can sometimes convert them later in Disk Utility. If your boot drive is a spinning hard disk, or if you're converting a non-bootable HFS volume, it's as simple as right-clicking the volume in Disk Utility and clicking Convert to APFS. If conversion isn't supported, the option will be grayed out. In every case except with Fusion drives, you can always copy the data to another volume, totally reformat it as APFS, and copy the data back. That Apple isn't ready to support Fusion drives in the initial High Sierra release gives me some pause. Hundreds of millions of iOS users have had APFS running in the real world for months with no serious issues, but I'm a little worried that it's not done enough to be used with Fusion drives, even though part of the point of APFS was to improve the way Fusion drives work. Apple is so adamant about its non-support for Fusion drives that the company actually requires you to reformat with HFS if you installed the public or developer betas on your system and already had your Fusion drive converted to APFS. Apple won't say when it plans to support APFS on Fusion drives. The conversion will probably happen as part of some future 10.13x update. Spinning hard drives are already supported but will never be converted automatically. Page 3. After the main blockbuster WWDC keynote, Apple does a big platform's State of the Union presentation aimed more specifically at the gathered audience of developers. It's nicely situated between the nitty-grittiness of the specific WWDC sessions and the bird's-eye overview you get in the general keynote, and it's always full of interesting tidbits. Buried in the presentation this year was news about the next phase of the Macos transition from 32-bit to 64-bit, a process that has been much longer and messier for the Mac than it was for iOS. Here's a really brief timeline. June 2003, the PowerPC G5 CPU is the first 64-bit capable chip to show up in a Mac, and with macOS by 10.3 Panther can theoretically address up to 8 GB of RAM. April 2005, macOS by 10.4 Tiger allows for 64-bit processors under the hood. They can be spun off from another processor run via the terminal. June 2005, Apple announces that it will begin using Intel processors, which are still primarily 32-bit. Whoops. August 2006, Apple launches the Intel Mac Pro with a 64-bit Woodcrest CPU. Mainstream 64-bit Core 2 Duo Macs follow shortly afterward. October 2007, macOS by 10.5 Leopard launches with actual support for regular 64-bit apps. Universal binaries can run on 32-bit and 64-bit Intel and PowerPC machines, covering 4 architectures within a single app. Unlike Windows, Apple never ships separate 32 and 64-bit versions of macOS X. August 2009, macOS by 10.6 Snow Leopard still runs on 32-bit chips, but for the first time everything from the apps to the OS kernel supports 64-bit operation. Snow Leopard's 64-bit capabilities are a major component of Apple's marketing push, which infamously includes no new features. However, most systems still default to loading the 32-bit kernel. July 2011, macOS by 10.7 line drops support for 32-bit Intel CPUs. Snow Leopard had already ended all support for PowerPC systems. Older Macs continue to default to the 32-bit kernel and 32-bit drivers, but new Macs launched in this era typically default to the 64-bit kernel. July 2012, OS by 10.8 Mountain Lion boots into the 64-bit kernel by default on all systems that support it, including a few that previously defaulted to the 32-bit kernel. In the process, a few 64-bit systems with 32-bit graphics drivers and 32-bit EFIs are dropped from the support list. That said, OS X can still run 32-bit apps. That brings us to today. Even in High Sierra, as of this writing, all of Apple's code is 64-bit, but you can continue to develop and run 32-bit apps, as long as there's not some other compatibility problem. But this is the beginning of the end. High Sierra will, in Apple's own words, be the last macOS release that can support 32-bit macOS apps without compromise. And for apps distributed through the Mac App Store, there are 2 new dates to add to the timeline. January 2018, all new apps submitted to the Mac App Store need to be 64-bit only. June 2018, all new apps and updates to existing apps submitted to the Mac App Store need to be 64-bit only. Apple HASNT clarified what without compromise means, and presumably 32-bit apps from outside the Mac App Store will continue to run for at least the next year or two, if only via some kind of Rosetta-esque downloadable compatibility layer. But sooner rather than later, Apple is going to strip all the 32-bit libraries, apps, and codes out of macOS, just like it already did in iOS 11 this year. This sounds disruptive, but, if anything, Apple has been remarkably conservative in its approach to 32-bit app support. It has been 6 years since a new Macos release ran on a 32-bit Mac. iOS went from entirely 32-bit to entirely 64-bit in just 4 years. Because developers have had so much time, most mainstream apps are already 64-bit. Of the apps I regularly use, only the Dropbox client, Adobe's apps, and the Audacity audio editing app are still 32-bit. The first two are pretty big, admittedly, though at least those companies have the resources to go 64-bit if Apple makes them put in the work. I'm sure there are lots of niche apps, particularly in businesses and schools, that are still 32-bit, either because they are not maintained or because upgrading to a newer 64-bit version would cost money that these places don't have. But for the majority of people, even if Apple shut 32-bit support off tomorrow, it wouldn't be a major problem. Finder and UI High Sierra is really a lot like Sierra. I wrote last year that, after years of constantly tweaking the appearance of buttons and scroll bars and other UI elements throughout MacOS' long life, things seem to have settled down post-iOS 8. That remains true in High Sierra, which changes essentially nothing about the way the operating system looks or works. Window management, mission control, the Today view and notification center column, iCloud integration, it's alright where Sierra left it. Last year's review is the best place to read about iCloud Desktop and Documents and the disk space management tools, which are almost the same in High Sierra. I say almost because Apple has added the ability to share files with other iCloud Drive users for collaborative editing from within apps or within the Finder. Open the iCloud Drive folder or anything in your desktop or Documents folders. If you're syncing the data with iCloud, right-click a file, head to the Share menu, and click Add People if your app uses Apple's default Share menu. You can also share files from there as long as the file you have open is saved to iCloud Drive somewhere. Sharing a file through iCloud. The UI looks the same as the one already in the Notes app. Sending a link via Messages. Once it's shared, you control access to your file from here. For that, sharing files works the same way it did in the Notes app in Sierra. Choose another High Sierra or iOS 11 user to share the file with, choose how to send them the link, and choose the level of access you'd like to give them, and you're done. The title bar will indicate when a file is shared, and the Add People entry in the Share menu becomes a Show People entry. You can click to add more users, change access levels, remove users, or stop sharing entirely. Contacts you've shared with recently also show up in the Share menu so you can quickly share other files with them. The method you use to share the file is saved too. Another minor tweak arrives in the form of a new variant of the San Francisco typeface called San Francisco Pro that doesn't replace the default system typeface but is available for use in apps and becomes the new default typeface in Notes. It's similar to San Francisco, but you can spot minor differences if you look at them side by side. The lowercases are a dead giveaway. The mono-spaced version of San Francisco SF Mono that iOS 11 uses in a couple of places is only visible in Macos in the terminal, where it can replace the default Andale Mono if you want it to, but this was also available in Sierra. Some of the additions that are in High Sierra will only be visible if you use certain apps in certain ways or if you own certain Mac hardware. For example, in Sierra, Apple added tabs to a bunch of first-party apps, including Maps, TextEdit, Terminal, Pages, Keynote, and others. Apple also opened the feature up to third parties as an API so they could put tabs in their own apps. High Sierra adds a new Show All Tabs screen that displays thumbnail versions of all the tabs you have open, a la Safari. Developers already using the tabs should get this new view for free with no update required. The main issue, apart from the fact that I haven't actually seen the tabs picked up in any of the third-party apps I use daily, is that implementation is inconsistent from app to app even within Apple's own apps. Sometimes the command keyboard shortcut works, sometimes it doesn't. The Finder doesn't get a Show All Tabs mode, for whatever reason. And High Sierra doesn't fix any of this stuff. Enlarge the touch bar gets new color picker options in High Sierra. Touch Bar MacBook Pro owners may also notice a few new controls Apple has added to the default set of capabilities developers can control. When viewing a color picker, developers could previously choose to display either a few basic colors or a bar with a wide spectrum of colors. In High Sierra, developers also get grayscale, RGB, and CMYK color pickers, along with a swatches view that can display the user's saved colors in apps like Keynote. All things considered, though, High Sierra leaves the Macos user interface and the Finder right where Sierra left them, and Sierra in turn didn't do much to build upon the UI tweaks and window management features El Capitan introduced 2 years ago. You'll feel right at home, at least. Page 4. Siri's new orb design is in Macos too. Flight status checking is Spotlight's main new trick. Apple revamped Spotlight's look, feel, and behavior back in Yosemite, and since then it has been incrementally improving the way Spotlight handles natural language queries and pulls in data from outside sources. This year's sole major addition is flight status updates. Type a code like AA4584 into Spotlight, and a window with the flight's path, status, and departure arrival information pops up in Spotlight's preview panel. Apple appears to be pulling this data from flightstats.com. Double-click the result in Spotlight to open the page for your flight in your default browser. Compared to the same functionality Google offers, though, Apple's isn't quite as smart. Searching for strictly formatted flight numbers in Spotlight like AA4584 or the X1183 works fine. Typing American 171 works fine in both Spotlight and Google, while Virgin 1183 works in Google but not Spotlight. This is the kind of edge case in which Apple's privacy-centric approach to search is the most limiting. Google has reams of data on what people are actually typing into the box and the results they expect to see when they type certain things. Apple's system, while ostensibly better for user privacy, isn't as comprehensive. One Spotlight change for developers that may eventually trickle down to users is the addition of iOS Core Spotlight framework to High Sierra. Core Spotlight lets apps present their content to Spotlight for indexing, which could improve the utility of Spotlight if, for example, your app connects to a cloud service that stores a lot of files, but those files aren't usually kept on disk for Spotlight's normal indexing to pick up. On Siri's side of the fence, the biggest change is the more natural voice you hear in iOS 11 and elsewhere. It's a huge improvement over what shipped with Sierra, which sounded considerably more stilted and robotic than the version in iOS 10. The new voice is also tied more deeply into Apple Music. Siri can tell you information about songs that are playing, can add songs to your queue, either specific songs, broader genre, or more like this type suggestions, and can just start playing random music, radio style, based on your instructions. Unfortunately, like most music-related Siri tech, it's Apple Music a bust if you want to use this stuff. By and large, though, my praise and criticism of Siri on the Mac remains the same as last year. Siri in Macos still feels like a tacked-in addition rather than an integral part of the platform. There are still no hands-free controls, and there are still a bunch of things that Siri can normally do that it can't do on the Mac. Why I still can't set a timer or control HomeKit from Macos is a mystery. I do like the ability to set up customizable control center widgets based on Siri searches, but while I interact with Siri once or twice per day on my iPhone and/or iPad and regularly on my Apple Watch, the only times I've used Siri on Mac over the past year are when I'm testing Siri. That won't be everyone's experience, but I don't think it's a great sign. Apps Photos. The Photos app. A few things to note: the reorganized sidebar, the new organizational categories, and the ability to view all your past imports and not just the most recent one. The new editing view. Note the new live photo editing options on the bottom. With the new live photo editing settings, you can create artsy long exposure shots if you'd like. Cropping images is easier and requires less clicking to experiment with different aspect ratios. Note in this section, we'll be detailing the differences in the Photos app itself. For more on HEIF and HEVC, the new image and video file formats in iOS 11 and Macos High Sierra, jump ahead to the section of the review that deals with under-the-hood technologies. The Photos app gets the single largest overhaul of any individual app in High Sierra. It adds new features, reorganizes existing ones, streamlines the editing interface to make it quicker to switch between different tasks, and adds support for third-party editing extensions that can seamlessly bounce photos out of third-party editing tools and then back to Photos when you're done. The first thing you'll notice about the user interface is that Apple has taken steps to tame the sidebar, which in Sierra just lumped a bunch of different categorization options at the same level of the menu. Now, the very broadest categories, photos, memories, favorites, people, places, imports, and recently deleted, all live at the top menu level under library, but all the media types, videos, live photos, selfies, and so on, are grouped together under one collapsible menu, and all your custom albums are grouped together in another menu. That imports menu marks the return of an iPhoto feature I've missed a lot since the original barebones Photos release back in Yosemite. To date, Photos has only let you view your last import, so it was really easy to find the last photos you imported and organize them into an album if you wanted, but you had to go digging through the rest of your photo library to find them. Because my iCloud photo library is a wide-ranging mix of photos taken with my phone mostly for fun and photos imported from my big camera's SD card mostly for work, it became annoying if I needed to find a batch of photos I had imported for a particular product review. The new Imports menu lets you scroll up through multiple imports, which are organized by date and can be filtered further by media type, whether you've edited them and whether you've added them to favorites. The latter filtering menu is actually present in every screen in the app, and you can also add filtering keywords to help you find specific kinds of photos. If you use iCloud to sync your photo library between devices, identifying people syncs between your devices now, too, so you don't have to repeat organizational work on every iDevice and Mac you touch. These new navigation options are nice, but at the heart of the new Photos app is a completely revamped editing interface that's more powerful and a lot quicker to use. In older versions of Photos, when you hit the edit button, you would choose how you wanted to edit the photo using 8 options on the right side of the screen. The Auto Enhance magic wand sat next to buttons for rotating, cropping, adding filters, retouching trouble spots, removing red eye, and opening third-party editing extensions. The most significant was simply labeled Adjust, and it had a ton of manual settings for adjusting colors, exposure, and white balance. The Adjust menu also had a bunch of hidden by default optional settings you could enable and customize to expose the tools you used the most. It all added up to an editing experience that was usable but required a lot of fiddling and clicking and switching contexts. The new app reorganizes things, showing everything you can do at once. The Adjust view is now the default view, and the settings for retouching spots and getting rid of red eye are tucked in among the standard brightness and color settings. New editing options include the handy Photoshop-esque curves tool and a selective color tool that allows you to set hue, luminance, and saturation levels for individual colors in an image. Previously, these settings were all or nothing. Other settings, the Instagrammy photo filters and the crop button, now with aspect ratio settings that aren't hidden behind a menu, are at the top center of the screen, and the Rotate, Auto Enhance, and Extensions buttons are in the top right corner. If you're editing a live photo, you'll also see the same new live photo editing controls you get in iOS 11. You can choose a new keyframe, create different photo loops, disable and re-enable audio and the live photo animation altogether. If that was all Apple had added to the Photos app, it would be a pretty solid update. But there's also a new type of extension specifically related to projects, a category normally restricted to digital slideshows and physical books, calendars, cards, and prints that can be ordered through Photos. Previously, Photos extensions were exclusively used for editing photos themselves, but these new ones also let third parties make new stuff from your edited photos. Apple sent along a handful of project extensions for us to try out. From directly within the Photos app, third parties like Wix, Mimeo, and Shutterfly can now let you create digital or web photo galleries and all kinds of printed products. And when you start one of these projects, it shows up under the My Projects menu along with all of the stuff made with Apple's first-party tools. If you want to see the full range of apps that offer project creation extensions, go to the File menu, then to Create, and then click on More to bounce out to the Mac App Store. Developers who choose not to use the Mac App Store can provide these extensions, too. They'll just have to advertise them by themselves. Other features that bear mentioning but are pretty self-explanatory: animated GIFs are natively supported and available in the Media Types menu. You can import things directly into an album and export albums as folders, and you get the same tweaks to the Memories feature that you get in iOS. Page 5 Reader View can now be set on a per-site basis, or you can just switch it on for all sites always. A bunch of settings have been condensed onto this handy screen. The new cookie tracking options. You get a lot of the new Safari improvements in regular Sierra and El Capitan, but you're stuck with the old cookie tracking settings. New HTML5 video playback UI. When it's running on High Sierra, Safari 11 gets the same big features on the Mac as it does in iOS. Let's begin with Reader View. This little button on the left side of the address bar strips away all the special formatting and the ads of articles that you are reading in order to make pages faster and more legible. Long-click on the Reader View button in iOS 11, and you'll be given the option to toggle a new feature called Automatic Reader View for the site you're visiting. Click the Reader Website's Preferences button to dive into Safari's settings, and you can toggle the setting for websites you've already configured, ones you've visited recently, or for all sites you visit. If you discover that a particular site has consistently awful formatting or ads, turn this on and you'll get a nice, clean view every time. The Websites tab in Safari's Preferences actually does a lot of other things, too, and gives you easy access to a wide range of settings. If any site has ever requested your permission to do anything, you can generally toggle it here. That includes website notification settings, camera and microphone access, and location access. This is where you'll find page zoom and content blocker settings, too. Plugins you've installed show up at the bottom of this list as well, and you can configure the behavior on different sites, just disable them entirely. Safari 11 and Safari in iOS 11 both support WebTC, a set of APIs that enables easy in-browser video and audio chatting without the external plugins that services like Zoom or GoToMeeting currently require. This is obviously more significant for businesses than for regular people. They'll normally use a separate app like FaceTime, Skype, or Google Hangouts for this kind of stuff. But Safari was the last of the major browsers to lack any support at all for WebTC, so it's a welcome addition. Head into the Safari settings and you'll see another new enabled by default feature that prevents advertisers from tracking you as you move from site to site. Called Intelligent Tracking Prevention, it's something that is being built into the WebKit engine that powers both the Macos and iOS versions of Safari. The feature works by collecting statistics locally on your device, for privacy's sake, on the pages you load, the links you open, and the text you enter. Based on the top-level domain's TLD of the contents loaded over time and how often the user actually intentionally visits or interacts with that domain, Intelligent Tracking Prevention makes assumptions about which sites are tracking you without your knowledge and responds accordingly. The cache of data and cookies associated with bad TLDs is regularly cleared and not stored. Sites can still see that you've visited, but they can't see which other sites you've visited. This is a more intelligent, dynamic version of Sierra's default Allow Cookies from Websites I Visit setting, which has been removed in High Sierra. You can still elect to block all cookies universally, though. Before, you could visit a site just by loading some script as part of an ad on a site that you actually meant to go to. Now, Safari can at least theoretically tell the difference between a site you visited on purpose and one that you unintentionally loaded something from. Privacy should improve without affecting the functionality of sites that use cookies and locally stored data for legitimate purposes. In the months I've been using High Sierra and iOS 11, I haven't noticed any sites I actually use working differently than they normally do. Intelligent Tracking Prevention should be largely invisible for most people. What any of these changes will do to the revenue of ad-supported websites is anyone's guess, but browser developers like Apple and Google are increasingly moving to clamp down on the crappy, performance-sucking, privacy-invading ads that are overwhelmingly responsible for high memory, CPU, and battery usage on your device. Apple isn't shipping a straight-up ad blocker in Safari yet. You'll still need to rely on third-party content blockers for that, but it's not difficult to envision something like that happening a year or two down the line. Unlike in iOS, where first-party apps only get updated when the OS gets updated, Apple still updates Safari separately for people who choose to have to run older operating systems. As with security updates, these Safari updates are released for the two trailing versions of Macos, so both Sierra and El Capitan also get Safari 11. You may be reading this with it already. These updates typically include rendering engine updates and security patches and some subset of new features, but they don't include the full range of things you get running the newest browser on the newest OS. Safari 11 in Sierra and El Capitan includes the automatic reader view feature, attempts to stop auto-playing audio on websites, and updates HTML5 video and audio playback controls. But you don't get intelligent tracking prevention. Instead, you keep the same relatively rudimentary Alan-othering cookie controls you had before. Notes: you can't make new scans in Macos, but you can view and edit the ones you make in iOS. The original image is stored in Notes and synced, so you can make the full range of edits you can make on an iDevice markup mode aside. There are two changes of note in the Macos version of the Notes app. The first and smallest is the ability to pin notes to the top of your list by swiping from left to right over them. It's handy for notes that you don't edit often but need to access frequently. The second and only slightly less small is support for tables. It's nothing to get super excited about, but the controls for swapping rows and columns are slick and intuitive. The Notes app in iOS 11 picked up a bunch of extra features related to sketches and handwriting recognition, but the Macos version still won't let you write or draw on things. The guaranteed presence of some kind of hardware keyboard is always going to be more convenient for writing anyway. You can, however, view handwritten notes and sketches synced over from your iOS devices, and handwritten text is searchable within Notes the same way it is in iOS. This is typical of the Macosios divide. Core technology is shared, and most things sync over, but the Mac ends up with a smaller subset of features in the end. The document scanner from iOS 11 isn't supported here either, which makes sense. Holding a document up in front of a webcam doesn't make a lot of sense anyway, and even the best Mac webcams are easily worse than the lowest quality rear-facing cameras in old iOS 11 hardware like the iPhone 5s and iPad Air. But, as with sketches, Macs can easily view scanned attachments, edit them, and export them to PDF. You can even tweak the color and corner detection of the scans, just as if you were editing the original on your device. Server stuff. Caching server, a feature which jumps from Macos server to plain old Macos. Set a quota to make sure the caching server doesn't take up all your space. Look at the advanced options to find more file sharing settings and time machine server settings. Any Mac can now be a time machine server. I used to write big reviews of Macos server. I don't anymore, partly because it's a slowly dying product and partly because my life is finite. But a working knowledge of server is important too. Understanding a couple of High Sierra additions that aren't being talked about but which might be useful for some people. The release notes for Server 5X, the High Sierra update to the software, says that 3 prominent services have been removed from server.app and integrated into Macos itself. Those services, in approximate order of usefulness, are the caching server, the advanced file sharing options, and time machine server. These features will mostly be useful to people who have multiple Macs or Y devices, plus a Mac Mini or iMac with a large internal or external drive with plenty of available storage. Not the widest possible audience, but not nobody. Caching server. This one's pretty cool. Say you have 3 Macs and 4 or 5 iDevices in your house. Anytime any of those devices need an OS update or App Store app update, they go out to Apple's servers, they download it, and they install it. Enable caching server on any Mac on your home network, though, and the first time any device requests an update, the computer will download and store a local copy. When subsequent devices request the same update, they grab the cached copy from the Mac instead of Apple's servers. This increases speed and reduces your bandwidth used. Apple's help files provide more details on how it works, but that's more or less all you need to know. Caching server stores a whole bunch of different stuff aside from updates, including internet recovery files for Macs, iCloud files, and over-the-air updates for Apple TVs. Apple keeps an updated list of cacheable content here. Though the version of the caching service in Macos server was never especially customizable or complicated, the High Sierra version's UI doesn't expose any settings for getting updates to separate subnets or anything like that. Caching was always one of the more homeosery server features, and, in High Sierra, it's presented as simply as it possibly could be. Head to the sharing settings, go to the new content caching setting, and check the box. Things will start working after that. You can choose whether to cache iCloud content checked by default or share cached content and your Mac's internet connection with iDevices connected via USB not checked. You'll also probably want to hit that Options button, because that's where you dictate how much of your Mac's disk space you want to devote to storing cached content. The default setting is unlimited, but even setting 20 or 30 gigabytes aside for updates is probably enough to make a noticeable difference when it's time to download another 3 gigabytes Macos Point update to all your computers. If the caching service runs out of room, it just deletes old stuff to make room for new stuff. Easy peasy. Advanced file sharing. All Macs support basic network file sharing over SMB and AFP. SMB has been Windows' default file sharing protocol for years and Apple's default since Mavericks, while AFP is an older, Apple-developed protocol that's now deprecated and will not, in fact, work with APFS. But the only options you really had in older versions of Macos was which folders to share, who to share them with, and what protocol to use. High Sierra adds a couple of other options, accessible by right-clicking your shared folder in the Sharing Preference pane and clicking Advanced Options. There's still not a ton here, but you can decide whether to allow guest users and only allow encrypted SMB connections, something that reduces performance but protects your data while it's in flight. Time Machine Server. More interestingly, these advanced options allow you to use your Mac as a Time Machine backup server for the other Macs on your network. From the Advanced Options menu, check the box to allow other Macs to see your AirSAT server as a Time Machine backup destination. You don't need to create a Time Machine backup folder that's separate from your normal file shares, but it keeps things cleaner and lets you restrict access to your backups if you don't want everyone you share files with to see them. You can set a quota to restrict backup size, which will limit the number of file copies Time Machine can keep around, but will also keep the hard drive on your server Mac from completely filling up with backup data. All Macs going back to Mavericks should respect this quota. Anything running an older version of Macos, maybe you have a PowerPC, a 32-bit Intel Mac that you still use for whatever reason, can see the server and back up to it, but it won't obey the limit. A NAS or an external drive attached to a router may still be a better home Time Machine server in the end, since they only consume a fraction of the power of a full desktop Mac. But the extra flexibility is nice to have, and building the feature into every Mac could lead to some creative solutions, using each Mac laptop in your house as a backup destination for one of the others, for instance. Page 6. This one has been a long time coming. The Mac finally has a new default file system. The Apple File System, or APFS, was first shown to the public as an unfinished beta in Macos Sierra, one that was mostly feature-complete but still couldn't be used for bootable volumes or accessed outside of the command line. Now, as long as you've got a Mac with all flash storage, you'll start using it right after you install High Sierra. APFS replaces HFS, a 19-year-old file system introduced in Mac OS 8.1 and one that merely built on top of 1985's original HFS from System 2.1. Apple has tweaked HFS and built on top of it to extend its capabilities over the years, most notably with Core Storage in Lion, a logical volume manager that enabled the full disk version of Filevault encryption and Fusion drives, among other features. But HFS and Core Storage still lacked key features of newer, more modern file systems. We've covered the core features of APFS several times at this point, so I won't repeat all of that information here. Read the APFS section in our Sierra review. This overview from Adam Leventhal, and Leventhal's in-depth testing of APFS snapshot feature if you're interested in getting into the details. But, in brief, here are the flagship features that APFS includes that HFS doesn't, and brief explanations of what they mean for regular people. Native encryption support. In particular, APFS supports multi-key encryption, where different keys can be used to encrypt user data, metadata, and individual pieces of files. This primarily reflects how encryption is used in iOS, not Macos. We'll cover how Filevault works in High Sierra later. Snapshots. Think about how Time Machine can store multiple backups of your files continuously so that you can restore your drive to exactly where it was at a given point in time. APFS snapshots work the same way, but they're even more space efficient. Each snapshot only records the changes you've made since the last one, and only new data takes up new space. APFS doesn't overhaul Time Machine, but it does begin the process. Space sharing. If you want to create multiple volumes on a single physical disk today, you need to decide up front how much space you want to allocate to each volume. If you overshoot, you might end up with wasted space. If you undershoot, you might need to resize and rearrange partitions later to make it work. In APFS, you don't worry about it. Every logical volume in an APFS container shares space with every other volume. If you have 200 gigabytes of free space on an APFS formatted disk with 6 different partitions on it, every one of those partitions can use as much or as little of the 200 gigabytes as it needs. Fast directory sizing. Have you ever clicked Get Info on a large folder to see how much space it takes up and then sat there for a couple of minutes while you waited for the folder size to be calculated? Well, APFS now stores metadata about file size separately in a place where it can be quickly accessed, instead of making the operating system dig through the metadata for all those files to calculate a folder's size. Viewing the size of a folder and how many files it has inside it should now be faster overall. Cloning. If you copy a file or folder from, say, your Documents folder to your desktop folder, APFS doesn't actually move data around, it just updates metadata to inform Macos that the data exists in 2 different places on the same disk. If you start editing one copy of the data, APFS will store both the changes and the original so that the original file doesn't change. User behavior doesn't need to change at all, but this means copying files around within the same APFS volume happens near instantaneously and takes up less space. Sparse files. If an app writes a large but empty file, let's call it 1 GB on an HFS volume, that file will take up the full 1 GB of space right from the get-go. Your computer can spend a bunch of time writing zeros to the disk, sapping disk performance, and wearing out your SSD, which can only be written to a limited number of times more quickly. APFS will mark the space as allocated so you don't accidentally run out of space on the disk, but will only actually write data to disk once there's real data there to write. Improving data integrity. Files sitting on a drive for a long time aren't necessarily static. Over time, hardware issues can corrupt that data, subtly changing it or corrupting it entirely. Not even common safeguards like mirrored RAIDs can correct for this all by themselves, since errors in the files can just be copied between 2 or more drives, corrupting all copies of the data on all the drives. The solution newer file systems use to correct for this is to check some written data, performing a mathematical function against chunks of data and then storing the results of that function. When the data is read, APFS will check some it again to make sure the results of the mathematical functions match. If they do, hooray, the data is probably the same as it was when you originally wrote it. If not, it's time to grab an older copy of the file from a backup to avoid corruption. Apple's implementation differs from the one used in a NAS and server-oriented file system like ZFS. It only checksums file metadata and not the files themselves, but the intent is basically the same. These aren't all the features APFS supports. There are a few other features that all aim to keep beach balls from happening, improve speeds for certain tasks, and reduce wear on SSDs, and a lot of the features above are enabled by APFS' ability to track down to the nanosecond when files are changed, but these are all the most important. Now let's dive into some apps adjacent features to give you some idea of where you will and won't notice the new file system day to day. Using disk utility with APFS. The default disk utility view of an APFS drive. Note that there's more than one volume in your volume. Partitioning a disk works the way it worked before, but you probably won't want to do this on APFS drives. What you actually want to do is create new APFS volumes, which can share space within the same APFS container. By default, any volume can use any amount of a container's available storage, but you can set limits too. This menu can let you see more. As you can see, each APFS volume is kept within the same container. The container is what you're actually creating when you make a new APFS partition. The extra volumes are hidden systems, things like the recovery volume. Viewing one volume tells you how much space is taken up by all of them. Sierra made APFS testers do everything through the command line, but High Sierra adds APFS-related controls to disk utility, and, if you ever mess around with the partitions on your Mac, it's actually important to understand the differences. Most people are going to be using Macs with one partition on one drive, but even if this describes you, Disk Utility is now going to tell you that the space on good old Macintosh HD is shared by multiple volumes. That's because your newly converted APFS partition is actually a container that can hold multiple volumes that all share the same pool of space. Hit the View drop-down button on the left side of the Disk Utility window, and you can see 3 different view options. The default just shows regular, non-hidden volumes, another hides the sidebar entirely, and another shows all devices. The latter option shows you both your physical storage devices, an HDD or SSD, for instance, as well as the APFS container that actually holds your main OS volume, the recovery partition, and a couple of other system partitions. It's important to understand the difference between creating a new APFS volume and creating a new partition. The latter function is still available if you hit the partition button, and it still uses the same pie chart graphics it has used since El Capitan. You can use this to create new non-OFS partitions on a disk. Boot Camp still needs to work this way, but to do so you're taking away space from the APFS container and all the volumes it contains. To add new APFS partitions to a single disk, use the New Volume buttons instead. This will let you add and delete new APFS volumes to the APFS container. Those volumes will show up in the Finder and the command line just as multiple HFS volumes would, but they all share the same pool of space and therefore more flexible than before. Adding a new volume doesn't reduce the amount of space available to existing volumes. If you need to make sure a certain amount of disk space is reserved for a given volume, or if you want to prevent any individual volume from taking up too much space on your disk, hit the Size Options button when you create a new APFS volume. Think of the reserve size as a minimum. The OS will reserve at least this much space for this volume's use, and of the quota size as a maximum. This volume will take up no more than this amount of space. These sizes are defined in gigabytes by default, but can also be measured in kilobytes, megabytes, terabytes, petabytes, and exabytes. APFS and Time Machine APFS also has benefits for local time machine snapshots, something that can normally take up quite a bit of space. Because of APFS support for snapshots, Time Machine no longer has to save multiple full copies of a file to your disk. It can just keep track of the specific changes. If you're editing a PowerPoint presentation, for instance, changing an individual slide with HFS means saving 2 copies of the file, one that records your new changes and one just in case you want to revert. Now, it can just save the original file plus a record of the differences between the original file and any updated versions, accomplishing the same task in substantially less space. And as with the Fusion Drive improvements, taking up less space on SSDs in particular means writing less data to the drive, which ultimately means a drive that's going to last longer. Apple says these changes won't be extended to normal Time Machine backups, mostly because of the number of variables at play, the file system of the target drive, the file sharing protocol being used for backups to networked storage, and so on. But APFS at least opens the door to more efficient, more granular Time Machine backups at some point in the future. APFS and Fusion Drive's APFS in this initial High Sierra release still doesn't support Fusion Drives, but Apple fully intends for APFS to replace and improve on the current core storage-based implementation. Fusion Drives were announced in 2012 to solve what was then a new problem. SSDs were fast but small and expensive, while HDDs were large and cheap but really slow. Combining the two to get the best of both worlds totally made sense, and still does in desktops. Despite the increased capacity and lower cost of SSDs in 2017, HFS has no idea what a Fusion Drive is. It can't distinguish an SSD from a spinning HDD, nor is it even aware that Fusion Drives are actually 2 disks presented to the operating system as a single volume. Apple relies on an underlying technology called core storage to do the heavy lifting here. It's core storage that combines the drives and presents them to the OS and the file system as a single disk, and it's core storage that's responsible for shunting data to and from your SSD depending on what apps and files you're accessing. But core storage has its own limitations. It's not a file system, and it's not actually aware of files. All core storage sees are blocks, and a block that contains essential system files looks the same as a block that contains, say, an application or a spreadsheet. Fusion Drive keeps track of how often blocks are accessed, and it moves frequently accessed blocks to the SSD while keeping infrequently used blocks on the spinning disk. APFS can avoid all of this. Like HFS, it is aware of files and is capable of telling the difference between them, but, like core storage, it can also handle combining drives and moving data around in the background. That's going to make Fusion drives a lot smarter in High Sierra than they currently are. For instance, APFS can tell the difference between different types of files. If you're frequently accessing something that takes up a lot of space but doesn't really benefit from extra storage speed, a video file, for instance, APFS can decide not to move that file to your SSD, freeing up more space for other things and reducing the amount of wear on the drive. APFS can also keep file metadata on the SSD while keeping files themselves on the spinning disk, speeding up spotlight searches and quick trips to get info windows. APFS and filevault encryption in large filevault is different under the hood, but you wouldn't know that to look at it. Apple's approach to disk encryption in High Sierra is Hippocratic: first do no harm. Or perhaps more accurately, first do not screw up anyone's established workflows. For the user's perspective, nothing about using filevault or APFS encrypted drives works any differently in High Sierra than it did in Sierra. Format a volume from disk utility, and you'll be asked to set a password to encrypt it. Set up filevault in System Preferences, and you're still given a key you can store locally or in your iCloud account, and you can still decide which of the computer's users is able to decrypt the drive's contents. But these UI similarities barely a significant, if ultimately not all that important, difference. Filevault in High Sierra isn't technically full disk encryption, it merely encrypts the parts of the disk that are actively being used. Other disk encryption systems, including Microsoft's BitLocker, offer this kind of encryption but also let you go ahead and encrypt all free space on the volume, too, if you want. Apple doesn't let you choose, and it doesn't even tell you there's a difference. In reality, the only way this would actually leave data unencrypted and recoverable is if you deleted a ton of sensitive files and then encrypted the drive, only to have your computer stolen immediately afterward. Realistically, a few days of writing data to the SSD would clear out the leftover unencrypted space. SSDs spread the writes out across the entire drive to ensure that the flash all wears out at the same rate, so any sections of the drive filled with deleted but recoverable data will be overwritten soon enough. Modern technology renders full disk encryption not especially necessary, at least not for most people. Notes on cloning: the actual real-world use cases for APFS cloning features are already pretty limited, and there are some other caveats you should know even if you think you'll benefit from the speed improvements and space savings. First, if you've already cloned a folder in Sierra and then you upgrade to High Sierra, that file or folder still takes up space and is stored twice after you upgrade to High Sierra. The upgrade and conversion process wisely only touches metadata without touching actual file data, so it won't proactively delete things that are stored twice. I cloned a 4.66 GB folder on a Sierra Mac and then upgraded to High Sierra. The extra 4.66 GB was still being stored on the disk. I deleted that folder and recloned it in High Sierra. From the user's perspective, this looks exactly the same when you viewed the folders and files in Finder, and APFS worked as intended, saving me almost all of that 4.66 GB of space. Second, the feature only works if you're copying data from one place on an APFS volume to another place on the same volume. If you copy the same folder down from a network share twice, the data will actually be copied and written twice. If you copy the files between two different APFS volumes in the same container, the data will actually be copied and written twice. Making the system work as users expect it will take precedence over proactively comparing file data and metadata and saving space. Compatibility with other OSes: HFS has been around for a long time. As a result, you can use older versions of Macos to read and write to HFS disks formatted with newer versions of Macos. Both read-only and read-write capabilities can be added to Windows and Linux, too. Apple's own Boot Camp software enables read-only access to HFS volumes, too. That changes with APFS. Apple says that it plans to document and publish the APFS volume format specification at some point, but, for now, the only operating system that can read and write to APFS volumes is High Sierra. You may be able to use Sierra, too, but its APFS implementation is incomplete and only intended for developer testing. You'll want to hold off on converting all your external disks until you're sure you'll only be using them with High Sierra Max. This is especially awkward for Boot Camp users. Even with the Boot Camp software installed, the current version as of this writing is 6.1. Windows can't even see that a Macos partition is present on your system, so if you try to use the Boot Camp control panel to change your startup disk or reboot into Macos, you'll just get an error. You'll need to restart your system while holding down the Alt key to go back to Macos, and you'll always need to go to Startup Disk in the System Preferences to set your default startup disk. Hopefully, Apple can at least fix this with an update, even if it can't give Boot Camp users the same access to the Macos partitions as before. Page 7. Before we talk about the new stuff in Metal 2, let's talk about how Metal versioning actually works PDF, since it's not quite as simple as rolling over from Metal version 1 to Metal version 2. For starters, Apple tracks the iOS, tvOS, and Macos versions of Metal separately. For there, Apple supports different Metal features on different hardware, and there are different versions of Metal for each major operating system release. So while Metal 2 is being marketed as the second version of the API, it's actually the third revision of the Macos version of the API. Apple groups GPU hardware together into families based on the Metal feature set they support. These families are tracked differently across the three different Metal-enabled operating systems. Each GPU family gets a different Metal version depending on which OS it's using. iOS GPU Family 1 refers to the Apple A7. iOS_GPU Family 1_V4 is the underhood name for Metal 2, since it's the fourth Metal release to cover the A7. GPU Family 2 refers to the Apple A8. iOS_GPU Family 2_V4 refers to Metal 2. GPU Family 3 refers to the Apple A9 and A10. iOS_GPU Family 3_V3 refers to Metal 2, since the A9 and A10 weren't around for the first release of Metal back in iOS 8. GPU Family 4 refers to the A11. iOS_GPU Family 4_V1 refers to Metal 2, since the A11 is brand new in iOS 11. tvOS GPU Family 1 refers to the Apple A8. tvOS_GPU Family 1_V3 refers to Metal 2. GPU Family 2 refers to the Apple A10X. tvOS_GPU Family 2_V1 refers to Metal 2. Macos GPU Family 1 covers all GPUs from the earliest 2012 era Metal Macs to the latest 2017 versions. Macos_GPU Family 1_V3 is the official name for Metal 2 in High Sierra, which you can actually see in the System Information app under Graphics Displays. It's accurate to say that every iDevice, Apple TV box, and Mac that supports the original Metal API also supports Metal 2, since they all benefit from at least a subset of its new features. On iOS, you'll only see the full benefits of Metal 2 on newer hardware, where all of its new features are supported. But the Mac still appears to be unified, at least for now. Apple has told me that the official, public-facing name has been updated to Metal 2, not because it's the first ever update to the Metal API, but, in part, because the API now does so many new things, including GPU and machine learning work, that it wanted to call renewed attention to the API. Metal isn't something regular users are going to interact with much except through the apps that use it, so we'll stick to the highlights. There are also some features that apply more directly to iOS that I covered in that review last week. The biggest change performance-wise is argument buffers, when Apple talks about Metal 2 being 100 times faster than OpenGL and 10 times faster than the original Metal. This is the specific thing it's talking about. Argument buffers are designed to make draw calls more efficient, allowing developers to render more objects on screen at once. In the original version of Metal, each draw call involved multiple separate API calls, which increased the amount of CPU time spent processing those calls. Argument buffers make it so that more can be stored in Metal's buffer, reducing the amount of API calls required to draw each object on screen. Not only does this reduce the amount of CPU time spent per draw call, but Apple says it also scales much better. This means that making additional draw calls does not necessarily consume a lot of extra CPU cycles. This doesn't magically translate into a frame rate that's somehow 100 times higher than what you can achieve in OpenGL. Argument buffers just present us with a hypothetical scenario that generates a nice big theoretical number that highlights one of the ways in which a low-overhead API is superior to a more conventional API. While both Macos and iOS still nominally support open, third-party APIs like OpenGL and OpenCL, it's clear that the company sees Metal as the way forward for graphics and GPU compute on its platforms. Apple's OpenGL support in Macos and iOS hasn't changed at all in years, and there are absolutely no signs that Apple plans to support Vulkan. It's not specifically a Metal 2 feature, but Macos does get one notable Metal tweak: High Sierra's Windows Server, the system process responsible for drawing all the stuff on your screen, runs through Metal now. Apple specifically says that this will help keep general UI performance smooth on lower-spec Macs. When you're using Mission Control on a 12-inch MacBook with a bunch of windows open, performance should be improved and more consistent in High Sierra. Of course, older non-Metal systems won't benefit, but it should be nice for newer but slower Macs. Finder freakouts like this one don't happen all the time, but I can get them to happen fairly reliably. Unfortunately, my experience with the new Metal-driven Windows Server hasn't been flawless. I've run into graphical glitching on both my MacBook Pro and iMac that have persisted into the GM build, and I've seen developers on Twitter posting about the same thing. Most of the glitches seem benign: blinking videos, web pages, or 3D graphics, but some seem serious. I can reliably make Finder windows flip out as in the GIF above, and older NVIDIA systems have been running into kernel panics throughout the beta process and into the GM. Hopefully, these are issues that can be ironed out in the first couple High Sierra updates and are not ongoing discovery-type problems that Apple needs to walk back. The normal path from GPU to screen. To support VR, Metal 2 lets developers bypass all of that. There are requirements you need to meet, though. A few Metal 2 features are related specifically to support for VR, also new to High Sierra. The most significant is called Direct-to-Display, and it's just what it sounds like. When you look at your monitor, you're normally not seeing direct output from the GPU. It's a combination of Metal-driven graphics and a bunch of different app windows and views, which can then have their color spaces adjusted for displaying DCI-P3 content on an sRGB monitor or vice versa, and get scaled for Retina displays before the completed image is actually shown on your screen. As long as the content and the display meet certain requirements, VR developers can bypass all that, sending graphics rendered in Metal straight to a display like, say, a VR headset without the extra latency and overhead required by all the other steps in the process. But having VR-friendly APIs and middleware, Unreal Engine and Unity, among others, have both come out in support of Metal 2 is just part of what you need to support VR. You also need the hardware, something that the Mac just couldn't do up until this year. And even then, getting a Mac with a built-in GPU that's good enough for VR requires you to drop at least $2,000 on a new iMac. That's where High Sierra's support for external Thunderbolt 3 GPU enclosures comes in. External GPU support, tested in large external CAT not included. Apple was an early and ardent adopter of Intel's Thunderbolt interface, and, for many years, the company was alone. Despite its speed advantage over even next-generation interfaces like USB 3.0, almost no PC laptops or desktops ever shipped with a first or second-gen Thunderbolt port, partly because of the added cost and complexity introduced by the separate Thunderbolt controller chip, and partly because there weren't many accessories available. The tide began to change with Thunderbolt 3. Because Intel was able to make Thunderbolt 3 a logical extension and superset of the emerging USB Type-C, PC makers seem more willing to include it in the high-end machines as a point of differentiation. It can drive displays, it can charge devices, and it supports both 40 gigabits per second Thunderbolt connections as well as 10 gigabits per second USB 3.1 Gen 2 connections. It's the ultimate do-everything port in an age when laptop designs called for fewer and smaller ports to save space. Now that Thunderbolt is faster and more ubiquitous, we're actually starting to see more accessories that take advantage of it, and external Thunderbolt GPU docks are the most interesting. External Thunderbolt graphics docks existed before, but the first two versions of Thunderbolt still didn't provide a ton of bandwidth from them relatively speaking, and neither Apple nor GPU makers officially supported them. That changes in High Sierra. GPU docks are now officially sanctioned and supported accessories, and the operating system is able to handle them gracefully, albeit with limitations. Any certified Thunderbolt 3 dock should work just fine with Macos, though that's dependent on whether the operating system supports the GPU you put in the dock. You may also be able to use graphics docks with Thunderbolt 2 Max with an adapter, but it only has half the bandwidth, and that's going to severely limit performance. At this point, I should say that external graphics support in High Sierra is by no means done, and Apple doesn't expect it to be ready for regular people to use until spring 2018. Incidentally, if you're placing bets on when the new Mac Pro is coming out, my money is currently on spring 2018. What's here basically works, but it's intended exclusively for developers. There are weird edge cases, and absent games don't always work right because they don't know how to handle multiple GPUs. A photo of the breakaway box from our review. The version Apple ships is in no way customized or changed from the normal model. Cooling fan, power supply, GPU outputs and the Thunderbolt 3 port. The board you plug the GPU into. A vent on the side helps with cooling, as does the vent on the other side. Apple sells an external graphics development kit to registered developers who want to take a leap of faith and start playing with external graphics support. That's what I did all my testing with. The kit is just a 350W Sonnet breakaway box with a Radeon RX 580 GPU in it. We've reviewed this enclosure already, and Apple's version isn't special. It's a functional but not especially aptly box with nothing in it but a power supply, a 120mm fan, and a simple board with a PCI Express slot on it. Apple still isn't ready to talk about which GPUs you'll be able to use with High Sierra when external graphics support is officially consumer-ready, but expect the official compatibility list to be restricted to a handful of recent, officially blessed models. Given Apple's preference for AMD over the last 4 or so years, it also guessed that AMD cards are more likely to be supported than NVIDIA cards. NVIDIA didn't respond to our questions about external graphics support in High Sierra, but if you want to decoder work in Macos, just prefer NVIDIA cards. It may still be possible once NVIDIA releases a High Sierra compatible version of its Mac driver package. Sonnet already has a use at your own risk set of directions for operating the breakaway box with NVIDIA GPUs under Sierra PDF. Even in its current partially finished state, Macos handles graphics docks fairly gracefully. Plug the box into a Thunderbolt 3 port in a MacBook Pro or an iMac, taking care to use the higher speed ports on the left side of a 13-inch Touch Bar MacBook Pro, and you'll get a notification telling you to log out before the external GPU can be enabled. Once you've done so, the GPU will show up in system information and will be usable by apps and games. Apple says the box provides 60W of power via the Thunderbolt cable, so you won't need to worry about plugging your power adapter in at the same time. When you want to unplug the GPU, it's probably best for the system if you log out or shut the system down beforehand. In my experience, though, you don't need to unplug the GPU from the Mac while you're logged in, and the screen will blink ominously for a second or so, but it appears to go back to using the internal GPU without crashing or kernel panicking, which is the intended behavior. Apple says that when you're plugged into the external GPU, the GPU handles all the graphics rendering on the system, including for the laptop's internal display. This is how external graphics docks already work in Windows. As of right now, though, many apps and games seem confused by the presence of the second GPU. The GFX Bench Metal benchmark, for example, would default to the Intel GPU in my MacBook Pro unless I attach an external monitor to the dock, made that external monitor the system's primary display, and then launch the app. Giving developers time to properly support multiple GPUs in a single system is one reason why Apple isn't pushing external graphics support for consumers yet. Other apps, like Geekbench 4 and CompuBench 2, see the multiple GPUs and let you choose which one you want to use to run your task. The APUs developers need to use to reduce this confusion already exist in Macos, but they're not always used. The dual GPU 2013 Mac Pro was a relatively niche system even when it was new, and in MacBook Pros with switchable graphics, the system will just run more demanding games and apps on the dedicated GPU without developers needing to target it specifically. Expect more apps to be able to target individual GPUs when if external GPUs become more prevalent. App issues and GPU support aside, the biggest limiting factor for external GPUs in Macos or any operating system is still going to be the speed of the external connection. Thunderbolt 3 is the fastest external I interface available, and its maximum speed of 40 gigabits per second is more than enough for plenty of tasks. But internal GPUs in mainstream desktops have 16 lanes of PCI Express 3.0 bandwidth available to them. Each lane provides a little less than 8 gigabits per second of bandwidth from the GPU to use, giving internal GPUs nearly 3 times the bandwidth as an external card connected over Thunderbolt 3. Even the mobile GPUs in 15-inch MacBook Pros have 8 lanes of PCI Express 3.0 bandwidth for a total of around 64 gigabits per second, to 50% more than Thunderbolt 3. The Breakaway Box reports that it has 4 lanes of PCI Express 3.0 bandwidth available to it, which, if accurate, means the GPU is working with about 32 gigabits per second of bandwidth. While our standalone Breakaway Box review focused on PC hardware, the principles are going to be exactly the same. Apps and games that need a ton of bandwidth and very low latency are going to fare the worst, since the interface will be the biggest bottleneck. Apple even says you should use a Thunderbolt 3 cable longer than the 18-inch-ish one included in the box, since adding more cable could potentially increase latency. Apps that aren't latency dependent, where the GPU is the bottleneck, will fare better. To test how external graphics support is shaping up, I ran a series of graphics and GPU benchmarks with a graphics stock on 2 different systems: a 2016 13-inch MacBook Pro with a dual-core 2.9 GHz Core i5-6267U, an Intel Iris 550 GPU, and 16 GB of RAM, and a 2017 5K iMac with a quad-core 4.2 GHz Core i7-7770K, an AMD Radeon Pro 580 GPU, and 24 GB of RAM. I wanted to test on these 2 systems specifically for a couple of different reasons. The MacBook Pro will show us how and if a dual-core laptop-class GPU will constrain a mid-range GPU like the RX 580. And the iMac will give us some idea of how an external GPU attached to a Mac will perform relative to a nearly equivalent internal GPU attached to a full 16 lanes of PCIe bandwidth. Despite the slightly different names, the iMac's internal Radeon Pro 580 GPU and the Radeon RX 580 are almost identical. They share the same architecture, same number of shaders, and same 8 GB of GDDR5 RAM. The only difference is that the external RX 580's core and memory clocks are 14% and 18% higher, respectively. It's as close to a straight comparison as we'll get, short of Hackintoshing or waiting for a new Mac Pro that can take regular PCI Express cards. Impressively, the 13-inch MacBook Pro keeps pace with the quad-core iMac pretty well. The main outlier is the GFX bench driver overhead test, which hits the CPU harder by making a bunch of draw calls. For games in particular, the CPU may become a bottleneck before the Thunderbolt interface becomes a bottleneck, but in these tests that isn't especially evident, and quad-core 13-inch MacBooks with Kaby Lake refresh CPUs in them will eliminate at least some of the potential CPU bottleneck. Anyway, what is evident is that an external graphics stock can provide a big performance boost over the integrated GPU, even if it's a mid-range card with only a quarter the normal bandwidth. The iMac results show where that interface is definitely slowing things down, though. The Geekbench OpenCL scores are similar, but the metal score of the external GPU is only half the score of the internal GPU. Even the internal Intel GPU in the MacBook Pro does almost as well as the external AMD GPU in this benchmark. This suggests that there will be cases in which Thunderbolt 3's speed renders an external GPU mostly pointless. In other tests, though, particularly the OpenCL Geekbench Compute test and some of the CompuBench rendering tests, we see the external RX 580 beating the iMax Radeon Pro 580 by a small amount, reflecting those higher core and memory clock speeds. It's great that High Sierra officially supports external graphics cards. And as technology improves, things should only get better. Pairing a 2016 MacBook Pro with a GPU in 2019 or 2020 could extend its useful life, and some future version of Thunderbolt that can deliver the equivalent of 8 lanes of PCIe 3.0 or PCIe 4.0 bandwidth will help relieve today's bottlenecks. It's not ready for prime time yet, but for a subset of people whose work benefits from a fast GPU, it's a promising start. PSA: no boot camp support for external GPUs. Apple explicitly does not support the external graphics development kit when running Windows on a Thunderbolt 3 Mac PDF. That doesn't mean it will never work, though I'd bet it's not a huge development priority for Apple. There are actually plenty of good Thunderbolt 3 laptops you can buy if using external graphics with Windows is what you really want. Page 8. High Sierra and iOS 11 introduce support for the high-efficiency video codec HEVC, sometimes called H.265, and the high-efficiency image file format HEIF. Eventually, these formats will completely supplant H.264 and JPEG, respectively, as the default movie and image formats in both iOS and Macos. Hardware limitations are going to draw the transition out over several years, though, despite Apple's tight control of its hardware and software. The goals of HEVC and HEIF are the same. Both can either maintain similar image quality at a lower file size or improve quality and/or resolution while keeping roughly the same file size. HEVC roughly doubles the compression ratio of H.264, enabling it to deliver similar video quality at around half the file size, a higher quality and resolution at the same file size. It's going to become increasingly important to both big companies and consumers as 4K content becomes more prevalent. Streaming providers like Netflix and Amazon will be able to provide higher resolution streams without quadrupling the costs, and people with new 4K capable phones will be able to shoot higher resolution video without eating up all their storage. HEVC also supports 8K video, laying the groundwork for even higher resolution video in the future. HEIF is just as interesting, and, if anything, it will make a bigger difference to normal people. That's because HEIF is not only capable of reducing the file size and increasing the quality of still images, but it can blur the lines between photos and video. It's a JPEG and a GIF replacement all in one. A HEIF file is actually a container for a whole lot of different stuff, allowing the format to natively support several things Apple is already doing. HEIF containers can natively store burst photos, something Apple supported with the iPhone 5S way back in 2013. HEIF supports simultaneous capture of video and still images as well as audio, which sounds an awful lot like the Live Photos feature added in the iPhone 6s. Individual HEIF files can contain both an edited image and its original copy, useful for preserving edits as you move a file from place to place. And the long exposure shots you can take with iOS 11 are made possible by HEIF's ability to store multiple shots within a single file. This page offers several fantastic examples of HEIF in action, though the images are obviously cherry-picked to emphasize the differences. Compared to GIF, HEIF files can offer dramatically smaller file sizes while simultaneously retaining more color data. Compared to JPEG, HEIF is noticeably less prone to obvious compression artifacts around the edges of objects, resulting in smoother-looking images. The benefits are real. Apple isn't exaggerating when it says that HEVC and HEIF files are half the size with no perceptible loss in image quality. Using photos and video taken with a 10.5-inch iPad Pro and an iPhone 7 Plus under both iOS 10 and iOS 11, I can confirm that still photos and videos in iOS 11 are almost exactly half the size that the same photos and videos were in iOS 10. The Ars WordPress CMS won't even let me upload HEIF files, so I've zipped up a few of them for you to check out if your OS or apps will let you if you don't want to do that. Here are some real-world file size comparisons. Test file iOS 10.3.3 file size iOS 11.0 HEIF HEVC file size difference 1.2 MP still image 2.1 megabytes 1 megabyte 1.1 megabytes 52% 1.2 MP live photo 2.6 megabytes 1.3 megabytes 1.3 megabytes 50% 20-second 1080p 30 video 41.4 megabytes 20.2 megabytes 21.2 megabytes 51% 20-second 1080p 60 video 60.6 megabytes 30.3 megabytes 30.3 megabytes 50% 20-second 4K 3.0 video 118.2 megabytes 58.2 megabytes 60 megabytes 51%. And even when you get enclosed, the new compression looks just about the same as the old compression. As usual, your lighting and camera settings will dictate how good your pictures and videos look, not the codecs being used to compress them. The iOS camera settings show updated file size information for the various video resolution and frame rate options. 1080p at 30 fps is still the default, but doubling your file size by recording 1080p at 60 fps or quadrupling it by recording 4K at 30 fps is suddenly a lot more palatable. Macs aren't cameras, at least not in the same way that iDevices are, so upgrading to High Sierra won't directly benefit you as much. Hardware requirements and compatibility. And now we come to the bad news. Only a small handful of current Macos and iOS devices includes special hardware that can natively encode and decode HEVC and HEIF files because of the newness of the codecs involved. Only Macs with Skylake and Kaby Lake processors support hardware-accelerated encoding and decoding of HEIF and HEVC files at all. This covers all Macs introduced in 2016 and 2017 and 5Ki Macs from late 2015. Only the Kaby Lake processors in 2017's Macs support hardware decoding of HEVC videos with 10-bit color, one of the few new features that separated Kaby Lake from Skylake in the first place. Why? It all comes down to whether your Mac includes the specialized hardware needed to encode and decode HEIF and HEVC files without stressing the main CPU and GPU. Here's everything that includes hardware decode support for HEVC and HEIF, meaning that they can play back files smoothly and with minimal impact on battery life or CPU-GPU load. If you've got an older device, and most of you will, the good news is that as long as it can run High Sierra or iOS 11, you'd get software decode support. That means the operating systems can use your device's main CPU and/or GPU to decode and view HEIF and HEVC videos instead. But especially with high-resolution HEVC videos, a lot of the older hardware won't be fast enough to play it smoothly. In those cases, the software decoding support is included mainly so that those older devices can still transfer and transcode the files even if they can't play them. Hardware support for encoding the files is even more limited, especially on the Mac. No Macs support hardware encoding of HEVC videos with 10-bit color, though all Macs support software encoding of these files, and no Macs support hardware or software encoding of HEIF files. I'm surprised that the latter isn't even an option. Why let QuickTime export HEVC videos but not let Photos export edited HEIF files? Apple says it plans to add HEIF encoding for Macs in a future release that could mean either a High Sierra update or the next major version of Macos. It's not clear which. In the meantime, I'll grant that it is more important on the iPhone, where people are creating new images all the time. HEIF in a JPEG world enlarge not ready for HEIF or HEVC. There's a setting for that. So some Apple devices can now create files with these formats, and all modern Apple devices can view them, one way or another. But outside of Apple's safe, controlled ecosystem, JPEG and H.264 are ubiquitous codecs that you can almost always assume support for. How do High Sierra and iOS 11 handle things when you take these new files off of your modern, freshly updated Apple devices and put them out into the world? Apple is going to provide API support for third parties so they can use and upload these files. If you're already relying on Apple frameworks like Core Image and AV Foundation in your apps, you'll usually pick up support for them for free in High Sierra. When you transfer a file via AirDrop, the device you're transferring files to will be able to tell you whether it's compatible with HEVC and HEIF. If so, the file is sent without transcoding. If not, it's transcoded to JPEG or H.264 automatically, and when you send an image or movie via mail or any share extension, Macos assumes the worst of whatever device might be on the receiving end. At least for now, all of these files will automatically be converted when they are sent. Enlarge the Photos app in Sierra can preview GIF images synced over iCloud but can't edit them. Finally, if you're using iCloud Photo Library or something else that syncs the GIF images you take between systems, any Macs still on Sierra and possibly older versions of Macos, though I haven't tested them myself, seem to be able to use Photos to view the files and export them as JPEGs for you, but the program can't edit them directly. If there's a major downside to both HEVC and GIF, it's that they are covered by patents that may need to be licensed for use in various apps and services. While this was the case for the H.264 codec, the HEVC codecs cost more. And as usual in the tech world, the needs served by HEVC and GIF are also covered by other, competing standards, many of them freely available. The most notable of those come from Google or have Google's blessing in some way. VP9 is a video format also covered by patents but available for free with conditions. It has gained wide support in modern browsers. Tellingly, Safari is the only major holdout. For still images, Google supports the WEBP still image format, though more recently the company has developed an improved JPEG compression algorithm that retains compatibility with anything that supports JPEGs, so everything. A 2-year-old group, including Microsoft, Google, Mozilla, Cisco, Intel, Netflix, and Amazon, has declared its intent to develop future open-source, royalty-free media formats for video, audio, and images. It does seem like industry support has mostly coalesced around HEVC at this point. Apple choosing it will give it a boost, but the format war is far from over. Core ML machine learning is one of those techno-jargon terms, like algorithm, or cloud, or engine, or service before it, that is used so broadly and generally that it barely means anything anymore. To take a crack at explaining it in layperson's terms, machine learning allows your device to recognize and categorize different kinds of data, automate repetitive tasks, and make intelligent guesses about current situations based on past situations. When the Photos app organizes your photos automatically and groups them together based on the faces in them, that's machine learning. When Safari decides to block a domain because it thinks you're being tracked against your will, that's machine learning. Apple's intent with the new Core ML framework is to package up some of the things it does in those first-party apps and make them possible for third-party apps to use. Developers can take a trained machine learning algorithm, package it up as an ML model, and integrate it into their apps. Apple offers a few default machine learning models that developers can download and use, or developers can use the open-source CORM tools to convert models made using other tools to make them CORM compatible. Apple says that machine learning models can be used to help with the following things: sentiment analysis, or looking at some text and figuring out from context for whether it's intended to be positive or negative. Handwriting recognition, translation, scene classification, or telling the difference between a house and a beach and the woods. Style transfer, or analyzing the artistic style of one image and applying it to a second, separate image. Magic tagging, or deciding what type of song a file is and tagging it accordingly. Predicting text. Core ML works in concert with the Vision framework to track objects like faces, text, rectangles, and barcodes. Apple uses this for QR code detection and document scanning in its own apps and with the natural language processing frameworks to better understand typed text and recognize names. Rather than sharing your data with a central server, grouping it together with a lot of other people's data, and improving machine learning models that way, Apple stresses that everything Core ML does is happening on the device. On Macs that support Metal, generally, Macs from 2012 and later, Core ML uses a mix of CPU processing and GPU processing, depending on the task. Apple tells us that older Macs without Metal support will still support Core ML, but it will fall back to CPU processing for anything. That those computers have slower processors anyway will just compound Core ML's slowness, but for the sake of adoption and platform unity, I'm glad it's still supported. Keeping everything local is a net positive for user privacy. It saves bandwidth, and it ensures that the apps work when your connectivity is poor or non-existent, but it does limit what developers can do. For instance, you can't do any training of algorithms on the device to improve the machine learning models. Developers will need to download new versions or train them elsewhere, make a new ML model file, and send it out. Apple tells us that developers can send out ML model updates without needing to issue a full app update, sort of like how content blockers can update the definitions without a full app update. AirPlay 2 doesn't radically change the kinds of things you can do with AirPlay. You can still share your screen, or cast a video to an Apple TV, or cast audio to an Apple TV-compatible third-party speakers and receivers. AirPlay 2 focuses mostly on audio, and it adds the ability to stream to speakers in multiple rooms, improved buffering to prevent skips and make playback more responsive, and the ability to control AirPlay audio from multiple Apple devices instead of only being able to control playback on the device that's streaming the audio. The biggest change is to the audio buffer. AirPlay 2 sends audio out to speakers faster than real time, and the speakers in turn can buffer minutes of audio at a time instead of just a few seconds as they do with AirPlay or plain old Bluetooth. Obviously, a larger buffer means playback won't be disrupted as often by wireless interference or a device momentarily going out of range. On Apple's end, it looks like all iDevices that get iOS 11, 4th generation and newer Apple TVs, and any High Sierra Macs that support the original AirPlay protocol should be fully compatible with AirPlay 2. The forthcoming HomePod will also support it. As for third-party speakers, some manufacturers have already committed to updating some AirPlay speakers to support AirPlay 2 via a firmware update, but it may not be possible for all existing devices. The new buffering system and syncing audio between multiple speakers at once presumably requires some extra memory and other hardware that older speakers may not have. Page 9. Open the Compose window in Mail while in full screen mode, and it will automatically pop up in split view mode. You can take live photos if you're on a FaceTime call with anyone using iOS 11 or High Sierra. Both people will be notified when either one takes the live photo. You can disable live photos in the FaceTime settings. Finally, as we do every year, there's a big pile of little things scattered throughout Macos that are significant enough to mention but small enough or self-explanatory enough that they don't merit a deeper exploration or explanation. Welcome to the grab bag. Mail. When you're using Mail in full screen mode and go to compose a new message, the Compose window automatically pops up beside the main window in split view mode. In Sierra, the Compose window obscures the main window and needs to be minimized and maximized if you want to look at different things. iOS. Apple also says that High Sierra compresses Mail messages, resulting in up to 35% space reduction. Obviously, your results will vary based on the size of your mailbox and the type of messages and attachments you're getting. FaceTime live photos. If you're in a FaceTime call with someone else running iOS 11 or High Sierra, tap the circular photo button to snap a live photo. You'll be alerted if the person on the other end of the call takes the live photo, and you can stop people from doing it by turning live photos off in the FaceTime settings. You still don't get full screen messages effects. I don't know if there are Mac users out there who truly feel like they're missing out on iMessage apps, since so many of them are a bit silly and inessential, but looking at Sent with Echo or Sent with Balloons continues to be a reminder that you're using a second-class version of the service. No more aim in messages. The Messages client still works fine with Jabber IM accounts, but support for AOL Instant Messenger and Bonjour has been removed. It's too bad if you like to use Messages as a unified, all-encompassing chat client, but there's always Adium. EFI Check. A new security tool called EFI Check that ships with High Sierra runs a weekly under-the-hood checkup, checking your system firmware against a list of known good firmware and making sure it hasn't been modified. Most Mac users will never see any evidence that it's running or doing anything. If the tool does detect something fishy, you'll see a nondescript warning dialog asking you to send a report to Apple, which may help the company diagnose the problem and come up with a fix in a series of deleted tweets. One of the tool's creators encouraged users to do this if you ever see the pop-up, but specifically told Hackintosh users not to bother. Recommendations. Look before you leap. It's difficult to recommend against an iOS update, because to get new security updates, which you need to accept all the UI changes and feature updates. But the most urgent security fixes for High Sierra will be distributed to Sierra and El Capitan, too. You've got some flexibility. I've been using High Sierra for months, and I'll continue to use it. I think the vast majority of people who decide to upgrade on day one will be essentially fine. But if it's at all possible for you, you should wait for version 10.13.1 or 10.13.2 to update to High Sierra. Aside from the fact that you'll keep getting security and Safari updates in Sierra, I make this recommendation for 3 reasons. The number of user-facing improvements is small. The Photos app gets the biggest overhaul, and it's a good one, but otherwise you're not missing very much. Some things just aren't done. APFS won't work on Fusion drives. External graphics support is usable but not finished. iMessage on iCloud isn't here yet. The new metal-powered Windows Server is still intermittently buggy. Even with fully finished bug-free features, Apple has been clear that these are foundational updates. Meaning cool, user-visible stuff will be built on top of them in future releases, but that stuff isn't here yet. High Sierra's first major update should hit in October-ish, around the same time as iOS 11.1, and the iPhone by 10.13.2 should hit before the end of the year. I don't know what those updates will include, but they usually squash the worst of the bugs and solve problems people inevitably run into while upgrading. If you upgrade, make sure you have good backups and make sure you're okay with doing a clean install if anything goes bad. But assuming you're still running El Capitan Sierra and you're happy with how your system is running right now, this year in particular is a good one to sit back and let other people work out the bugs before you dive in. Conclusions. The stage is set. I've written and deleted and rewritten this section of the review twice now, because despite using it for months and diving deeper into it than most people will bother to, I'm still not sure what to think of High Sierra. On the one hand, the release intentionally evokes Snow Leopard in its focus on low-level technologies and foundational improvements. There are bugs, and there's stuff that's not done, but Snow Leopard wasn't perfect when it was released, either. On the other hand, look at iOS. Has there been a year, ever, where iOS took a year off to focus on foundational technologies, leaving the rest of the UI and the vast majority of the apps mostly untouched? No. iOS 11 gets just as many foundational tweaks as High Sierra, but it also added things to most of the major first-party apps, completely rethought the iPad multitasking model, overhauled the Control Center, Notification Center, and Lock Screen, launched a whole new augmented reality platform, and swept away the last remnants of 32-bit support from the iOS codebase. iOS switched to APFS in a mid-year point update. The rate of change, largely beneficial change, not just change for change's sake, doesn't even compare. It doesn't help that High Sierra also feels like it's in catch-up mode. External graphics and VR are both things that other platforms have supported for years, and a proper replacement for HFS has been due for at least a decade. Of course, Apple is going to devote more resources to the operating system that represents 70% of its business, and, of course, adding improvements to a mature, complex, 16-year-old desktop operating system that grew from 28-year-old roots is more difficult and time-consuming than adding stuff to a phone OS that came out barely a decade ago and is still stretching its legs. But post-iOS updates have all felt quiet and incremental and small and safe, and I'd really like to see something that isn't just a slightly improved version of a thing I already have. Ultimately, I think we'll judge High Sierra based on what comes after it. To throw out some building metaphors, it's really hard to judge what a building is going to look like if you can only see the foundation. I hope the work Apple has done here helps it tackle some of the Mac's biggest long-term issues. Apple's own first-party apps and services, most notably Messages and Siri, are still less capable on the Mac than they are on Apple's other platform, despite sharing most of the same core technology. And the Mac App Store is still less healthy and vibrant than the iOS App Store. At this point, the iOS watchOS and tvOS stores are all interlinked, and Macos is out in the cold. High Sierra is by no means a bad update, at least it won't be after the bugs are ironed out and the features are finished, but it's also invisible by design. High Sierra's new file system and APFS provide the Mac with a stronger foundation than ever, and the slowly approaching death of 32-bit apps suggests that Apple wants to rip out some of the operating system's legacy cruft. And all my hardware complaints from last year's review have been totally wiped out by not one but two MacBook Pro updates, a MacBook refresh, revamped Thunderbolt 3 iMacs, a peek at an iMac Pro that looks ridiculously powerful and expensive, and the promise of a new Mac Pro tower to come. The stage has been set for a big, rethought, flashy, forward-looking version of Macos. I hope we get it soon.